Hello everyone. My name is Shreya and I am assistant professor at ABES Engineering College, Ghaziabad. Today I am going to discuss the topic applications of soft computing. So here is the content which we are going to discuss today. First is the introduction of soft computing. What is soft computing? So we are going to discuss what is soft computing. Then we will discuss what is the problem solving techniques. Basically here we will discuss two types of problem solving techniques. One is hard computing and another is soft computing. After that, we will discuss what is the difference between hard computing and the soft computing. After the difference between hard and soft computing, we will see the exact definition of soft computing and what is the goal of soft computing and what are the different applications. So, what is the soft computing? In computer science language, we can say that the soft computing is a term which is used in computer science to refer to the problems whose solutions are unpredictable or uncertain between 0 and 1. There are some problems in computer science which cannot be defined in between 0 and 1. It can be a values in between 0 and 1. Then we will use the soft computing. It is basically designed to model the solutions to the real world problems which are not modeled or which are too difficult to model mathematically. Like we can take an example of a bank where a person or you can say the account holder is verified after the signature verifications, and this can be done through soft computing. So this is the soft computing. So let us discuss first what is the problem solving technique. In computer science language, we can say when a problem comes, it is basically divided into two parts. One is hard computing and another is soft computing. So in simple language, hard computing basically deals with the precise models where the solutions are accurate. It can be achieved quickly in the form of 0 and 1. But in soft computing, it deals with the approximate models. It means these results are not accurate. These are just approximated values. And it is basically used for the complex problems, which are non-linear problems. It can be said as a non-linear problems. There the soft computing is used. So this is the flow chart which can explain hard computing and soft computing in details. Here we can see that the hard computing basically deals with the precise models, or it uses some traditional numerical modeling or calculations and search. These are the examples of precise model which are used to solve the precise models, which are used to solve the solutions, which are used to get the solutions for the precise models, and it can use some symbolic logical reasonings. But in soft computing, we can see that the soft computing approximate models are used. So it is applicable for the approximate models since it cannot give the accurate values. So it uses some approximate reasonings, and some functional approximation and randomized search are used in the soft computing. Here are some basic difference between hard computing and soft computing. The first one is hard computing works well for the simpler problems where the problem is simple and the value is or the result it can be predicted in the form of 0 or 1. It can be said, it can be verified in the form of true or false. But in soft computing, it is well suited for the real world problems. The real world problems can be defined, it can be used in the banking problems or in stock marketing where the values are only approximated. The value is not fixed. So it is well suited for the real world problems. Second difference is that hard computing requires precisely state analytical model, but it uses the precise models. But soft computing is basically for the tolerant of imprecision, uncertainty, and the partial truth and approximation. Third difference is that hard computing requires full truth, since it have to give the problem solutions in the form of yes or no. So it requires full truth. But soft computing can work with the partial truth. It doesn't require the fixed you can say the accurate values, so it can work also with the partial truth. Next one is that hard computing is precise and accurate, but the soft computing is imprecise. The value is in the form of approximations. Next is difference is that hard computing basically uses two valued logics. One is 0 and another is 1. If the result is in the positive way, if it is true, then the value and the result is in the form of 1. But if the solutions is in negative way, in negative forms, then the value is in the form of 0. Soft computing can use multi-valued logics, but the soft computing can use the multiple valued logics. For example, if the result is in the form of 0.20, in the form of 0.25, or 0.280, then it can be used the multi-valued logics. For this, we will see the fuzzy logics and its script sets and so many memberships in the next lecture. And the last difference can be defined that hard computing often requires a lot of computational time. Obviously, it uses some traditional mathematical formulas and calculations to solve the problem. So it requires a lot of computation time. But soft computing requires a reasonably less time as compared to the hard computing. So hard computing. So the main difference here can be defined in the form of memory, which is used in hard computing and models and in the soft computing models. After that, we can see the definitions of soft computing. It can be defined in the form of three combinations. One is neural network, second is fuzzy logic, one is neural network, second is fuzzy logic, and the last one is genetic algorithms. So in simple terms, we can say that software computing is basically these three terms combination. First is neural network. It is used for the learning and adaptation problems. For example, in human brains, neuron works. Same it is, the neural network also works in the approximate models. Second one is fuzzy logics. These are usually used for the representation of data. If the value is represented in the approximate models, or you can say the soft computing models, then we use the fuzzy logics to just represent the data. And basically, it is in the form of 0 and 1. And it can be any values in between 0 and 1. It can be 0.1, it can be 0.2, it can be 0.3. Any values in between 0 and 1 also. So this can be possible to represent the data with the help of fuzzy logics. We will discuss this fuzzy logics and all three terms in detail in the next lecture. So this is the fuzzy logics, and the last one is genetic algorithms. Basically, this genetic algorithm is used for the computational part. All the computational parts, all the evolutionary computation parts come into this genetic algorithm topic. So this is the in simpler way, we can say that soft computing, it is the use of approximate but usable solutions to the complex computational problems. If the problem is complex, then the soft computing use some approximate values to find the usable solution for any problem. So same line is written here, that soft computing is an emerging approach to computing which parallel the remarkable ability of the human mind to reason and to learn in an environment of uncertainty and imprisonment. Same discuss here that the soft computing consists of several computing paradigms. Mainly it is fuzzy logic, neural network, genetic algorithm. So now let us discuss what is the goal of soft computing. So this can be explained. Actually, any problem has some terms in it, like the problem of approximations, problem of uncertainty, and problem of imprison. These are the basic problems. This is the basic term in any problem. It can be in nonlinear problem or linear problem. These are the three terms which are important to find the answer, to find the solutions. So let us discuss firstly what is approximation. First is approximation. Firstly, we will discuss all these three terms. Then we will see what is the goal of soft computing. Firstly, we will learn what is approximation. Second, we will learn what is uncertainty. And third, we will what is imprison. imprecision. So let us discuss them first. First is approximation. What is approximation? It is here in soft computing, we can say approximations here is the model features which are not reals, but which are not the real, but we are using it to feel that this is the real values. So here the model features are not usable, are not similar to the real ones, but we are using but are not the same, but we are using it like a real one. So this is the approximations, the values should be approximated. It is only a predictable values. Second is uncertainty. What is uncertainty? Here we are not sure that the feature of the models are the same as the data of the entity or belief. So this is the uncertainty. Here in soft computing models, we are not sure that the models which are given here is same as the entity or beliefs which are already given in the problems. So this is the uncertainty. Last one is imprecision. What is imprecision? Here the model features are not the same as that of the real ones, but the close to them. So this is the imprecision. So basically, here the goal of any soft computing model is just to tolerate all three terms. First is approximation, uncertainty, and imprecisions. So the main goal of soft computing is to exploit the tolerance for approximation, uncertainty, imprecisions, and the partial truth in order to achieve close resemblance with human-like decision making. And another goal of soft computing is to develop intelligent machines to provide solutions to the real world problems which are not modeled or which are too difficult to model mathematically. So these two are the main goal of any soft computing. At last, we will say what is the applications of soft computing, why we are using the soft computing in real world. So first is here, it can be explained with the help of these 5 problems. First is signature verifications. And we can see that in banking sector, when there is a in all banks, there is the feature of signature verifications. If a person, even if a authorized person wants to figure out that, yes, I want to do some transactions or anything in bank, then the banking system use some signature verifications. And this feature can be used, can use the soft computing models for the signature verification. Second is medical imaging. In medical sector also the soft computing models can be used, like for the x-rays. And third is pattern matching. We can see the simple example of pattern matching in our cell phones. In real life, when we are using our phones, we just entered some pattern to enter in my phone, to enter in the smartphone. Same feature, it uses the soft computing features to match the pattern matching. What it does, there is some, you can say there is some values which are saved as a in the form of pattern. When a person enters the same pattern, it matches with the earlier with the authenticated values, authenticated patterns. If it match, then the person is allowed to enter in the phone system. So here the soft computing is used. Next is data mining. There are so many models which have lot of data in it. So here we can use soft computing with the help of fuzzy logics to mine the data. And at last, applications can be handwritten character recognitions. It can be applications of a soft computing. For example, if so many person write, you can say example, if so many person write a same value, but it can be written in the different forms. So here soft computing model is used and it gives output this is the correct one. So this is the handwritten character recognitions. So it is application of soft computing. So that's for all today. We will discuss fuzzy logic in the next topic. Thank you.